Yes, it is permissible to install a multi-wire branch circuit, also known as an MWBC, to a bedroom. It is acceptable to use one conductor for lighting and another for receptacles, sharing a neutral, according to the National Electrical Code, specifically the 2023 edition. Section 210.4 bone permits two or more branch circuits supplied from different phases of a polyphase system to occupy the same equipment, wiring enclosure, cable, or raceway, irrespective of the requirements outlined in Section 210.4a. Section 210.4 appertains to circuit identification and does not explicitly prohibit using different conductors of an MWBC to supply different types of loads, such as lighting and receptacles, within the same room. Consequently, installing an MWBC in a bedroom in the manner described is permissible, provided certain conditions are satisfied. Firstly, the MWBC must be properly identified. This identification must adhere to NEC Section 210.5c, which stipulates that each conductor of an MWBC be identified as a component of a multi-wire branch circuit. Secondly, the circuit conductors must be appropriately sized and protected. This requirement is based on NEC Sections 210.19 and 210.20a. The circuit conductors need to have the correct ampacity for the intended load and overcurrent protection suitable for the conductor size. Thirdly, the neutral conductor must be properly sized. This sizing must comply with NEC Sections 210.22 and 210.22b. The neutral conductor has to be large enough to carry the maximum unbalanced load. It is crucial to consult with a qualified electrician. An electrician can guarantee that the installation is carried out safely and in accordance with all relevant codes and standards. Now let's delve deeper into each of these requirements. Regarding the identification of the multi-wire branch circuit, NEC Section 210.5c is very specific. It requires that where an MWBC serves more than one receptacle or equipment on the same yoke, a means shall be provided at the origin of the branch circuit to identify each ungrounded conductor associated with the branch circuit at its point of origin. This identification can be achieved through various methods such as color coding, marking tape, tagging, or similar approved means. The goal here is to ensure that anyone working on the electrical system can easily identify all conductors belonging to the same MWBC, even if they are located in different parts of the building or panel board. This is particularly important during maintenance or troubleshooting to prevent accidental shorts or ground faults that could occur if the conductors are not properly identified. Moving on to the sizing and protection of the circuit conductors, NEC Section 210.19 provides detailed guidance on the minimum ampacity requirements for branch circuit conductors. The ampacity of the conductors must be sufficient to carry the non-continuous load plus 125% of the continuous load. A continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. The conductors must also be protected against overcurrent in accordance with NEC Section 210.20a, which requires that branch circuit overcurrent protection devices be rated in accordance with the conductor ampacity. This means that the circuit breaker or fuse protecting the circuit must not be rated higher than the ampacity of the conductors. For example, if the circuit conductors are rated for 20 amps, the overcurrent protection device must be rated at 20 amps or less. The sizing of the neutral conductor in an MWBC is governed by NEC Section 220.61. This section specifies the conditions under which the neutral conductor can be sized smaller than the ungrounded conductors. In general, the neutral conductor must have sufficient ampacity to carry the maximum unbalanced load. The unbalanced load is the maximum difference between the loads connected to the ungrounded conductors. However, there are some exceptions to this rule. For example, in dwelling units, the neutral conductor can be sized at 70% of the ungrounded conductors for ranges, ovens, and other cooking appliances. It is also important to note that the neutral conductor must never be smaller than the minimum size specified in NEC Table 310.16 for the corresponding ungrounded conductors. In addition to the requirements mentioned above, there are several other important considerations when installing an MWBC. Firstly, all devices connected to the MWBC must be rated for the voltage between the ungrounded conductors. For example, if the MWBC is supplied from a 240/120 volt system, all devices must be rated for 240 volts. Secondly, the MWBC must be provided with a means to disconnect all ungrounded conductors simultaneously. This can be achieved by using a multi-pole circuit breaker or a switch that disconnects all ungrounded conductors at the same time. Thirdly, the MWBC must be installed in accordance with all applicable codes and standards. This includes the NEC, as well as any local codes or regulations. It is also important to follow all manufacturers' instructions for the installation of the electrical equipment. In summary, installing an MWBC in a bedroom is permissible under the NEC, provided that certain conditions are met. These conditions include proper identification of the MWBC, appropriate sizing and protection of the circuit conductors, proper sizing of the neutral conductor, and compliance with all applicable codes and standards. Always consult with a qualified electrician to ensure that the installation is done safely and in accordance with all applicable codes and standards. A multi-wire branch circuit offers an efficient way to supply power in residential and commercial settings. By sharing a neutral conductor between two ungrounded conductors, it reduces the amount of wiring needed and can save on material costs. However, it is crucial to understand the requirements of the NEC to ensure a safe and compliant installation. One of the key advantages of using a multi-wire branch circuit is that it provides two circuits with a single neutral conductor. This can be particularly useful in bedrooms where you may have multiple receptacles and lighting fixtures. By using an MWBC, you can supply power to both the receptacles and the lighting fixtures without having to run separate circuits for each. This not only saves on wiring costs but also reduces the number of circuit breakers needed in the panel board. Another advantage of MWBCs is that they can help to reduce voltage drop. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. This can be caused by long wire runs or by high current loads. By using an MWBC, you can reduce the length of the wire runs and minimize the voltage drop. This can improve the performance of electrical equipment and prevent damage to sensitive electronics. However, there are also some potential disadvantages to using an MWBC. One of the main concerns is the possibility of an open neutral. If the neutral conductor in an MWBC becomes disconnected, the voltage on the two ungrounded conductors can become unbalanced. This can cause damage to electrical equipment and create a shock hazard. To prevent this from happening, it is important to ensure that the neutral conductor is properly sized and installed. It is also recommended to use a multi-wire branch circuit breaker that will trip both ungrounded conductors if the neutral conductor is interrupted. Another potential disadvantage of MWBCs is that they can be more difficult to troubleshoot than standard branch circuits. If there is a problem with an MWBC, it can be difficult to determine which conductor is causing the issue. This is because the two ungrounded conductors share a common neutral conductor. To troubleshoot an MWBC effectively, it is important to have a good understanding of how the circuit works and to use the appropriate testing equipment. Despite these potential disadvantages, multi-wire branch circuits are a safe and efficient way to supply power when installed correctly. By following the requirements of the NEC and using good workmanship practices, you can ensure that your MWBC installation is both safe and reliable. In addition to the specific requirements outlined in the NEC, there are also some general best practices that should be followed when installing an MWBC. Firstly, always use properly rated and sized conductors. This includes both the ungrounded conductors and the neutral conductor. The conductors should be sized according to the ampacity requirements of the circuit and should be protected by overcurrent protection devices that are rated appropriately. Secondly, always use a dedicated neutral conductor for each MWBC. Do not share a neutral conductor between multiple MWBCs. This can overload the neutral conductor and create a safety hazard. Thirdly, always terminate the neutral conductor at the neutral bar in the panel board. Do not splice or tap the neutral conductor in the field. This can create a high resistance connection that can cause voltage drop and overheating. Fourthly, always test the MWBC after installation to ensure that it is working properly. This includes checking the voltage between the ungrounded conductors and the neutral conductor, as well as verifying that the overcurrent protection devices are functioning correctly. Fifthly, always document the MWBC installation. This includes labeling the circuit breakers and conductors, as well as providing a wiring diagram. This will help to ensure that the MWBC can be easily identified and maintained in the future. In conclusion, the installation of a multi-wire branch circuit in a bedroom, using one conductor for lighting and the other for receptacles while sharing a neutral, is permissible under the NEC 2023, provided that certain conditions are met. These conditions include proper identification of the MWBC, appropriate sizing and protection of the circuit conductors, and proper sizing of the neutral conductor. It is also important to comply with all applicable codes and standards and to consult with a qualified electrician to ensure that the installation is done safely and correctly. By following these guidelines, you can ensure that your MWBC installation is both safe and efficient. Remember to consult with a qualified electrician to ensure compliance with local codes and regulations. Also, it is vital to stay updated with any amendments or interpretations of the NEC that may affect the installation. The NEC is a comprehensive document that is updated every 3 years, so it is important to stay informed about any changes or revisions. Furthermore, consider the specific needs of the bedroom when designing the MWBC. For example, if the bedroom is likely to have high-demand appliances such as air conditioners or space heaters, it may be necessary to increase the size of the circuit conductors to accommodate the increased load. Additionally, it is important to consider the placement of receptacles and lighting fixtures to ensure that they are conveniently located and meet the needs of the occupants. When installing receptacles in a bedroom, be sure to comply with the requirements of NEC Section 210.52, which specifies the spacing and location of receptacles in dwelling units. This section requires the receptacles be installed so that no point along the floor line in any wall space is more than 6 feet from a receptacle outlet. This ensures that occupants have easy access to electrical power without having to use extension cords. Also, consider using tamper-resistant receptacles, especially in bedrooms where children may be present. Tamper-resistant receptacles have internal shutters that prevent objects from being inserted into the slots, reducing the risk of electrical shock. When installing lighting fixtures in a bedroom, be sure to comply with the requirements of NEC Section 210.70, which specifies the location and type of lighting outlets required in dwelling units. This section requires that at least one wall switch-controlled lighting outlet be installed in every habitable room, including bedrooms. This ensures that occupants have convenient control over the lighting in the room. Also, consider using energy-efficient lighting fixtures such as LED fixtures to reduce energy consumption and save on electricity costs. In addition to the technical aspects of installing an MWBC, it is also important to consider the aesthetic aspects. Be sure to choose wiring devices and lighting fixtures that complement the decor of the bedroom. Also, consider using concealed wiring methods to minimize the visibility of wires and cables. This can help to create a more visually appealing and uncluttered space. Finally, it is important to educate the occupants of the bedroom about the safe use of electricity. This includes teaching them about the dangers of overloading circuits, the importance of using properly rated extension cords, and the risks of tampering with electrical equipment. By educating occupants about electrical safety, you can help to prevent accidents and injuries. In conclusion, installing a multi-wire branch circuit in a bedroom requires careful planning, attention to detail, and compliance with all applicable codes and standards. By following the guidelines outlined in this discussion and consulting with a qualified electrician, you can ensure that your MWBC installation is both safe, efficient, and meets the needs of the occupants.